Terrific.
Yeah.
I think I'm not sure if Vlad's online right now, so it might be good to get going. Oh, here he is. Never mind, bro.
All right. Who wants to go first?
Not me.
Well, somebody said, Vlad, you guys said that you had the a proof of the safety bounds on the Clique Oracle. Is that the case?
So like 2 weeks ago or so, we I guess we missed a lot of stand up, but there was at the there was a retreat in California, some research workshop thing, and we made some progress with some other people at the workshop. It's a semi involved update. I have a real quick one. I can probably go first, if that's cool. Just kind of get it out of the way.
Sure.
So not super researchy, but maybe interesting to you guys, at least for anyone who will be attending DevCon. We've submitted stuff like, the deadlines today essentially for talks and workshops and stuff. And the goal, I guess, at DevCon, if you're going to be there, is to have some workshops like going through some safety proofs and some protocol specifications, and also doing some stuff with crypto economics. So I submitted stuff on that yesterday. And I guess, yeah, that's pretty much my update. But if you're at DevCon, come hang.
Cool. When is DevCon?
October 30th to November 2nd, I believe.
Where is it?
It's in Prague.
Okay. Should I submit it to Casey? No, who should I submit it to?
Are you looking to do talk presentations?
Yeah.
There's a website. I'll ping you it.
Okay. Last few years they reached out to me. I guess I'm old news now.
Oh, this time everyone needs to go through the form.
Yeah, I think they're trying to be more organized this year. So
okay.
So Nate, are you sure you don't want to give the update with respect to the safety oracle too?
Sure, I can. I can give a high level overview. So Vlad and I have spent the past couple weeks trying to prove that a clique, which is this kind of like agreeing and see each other agreeing notion that we've talked about a couple times now. We've been trying to prove that this is a safety oracle if it is of a certain size. And the size that we were expecting was essentially 1/2 of the validator set plus the fault tolerance threshold, so T divided by 2. For now, let's just say that there are no equivocations anywhere. We can talk about those later. But essentially, we've been trying to prove that a clique, so people seeing each other agreeing of a certain size, namely 1/2 plus T over 2, is a safety oracle. And we haven't been able to complete the proof, which turns out was a good thing because it actually was not legit in that our weight condition was off. So pretty much a guy named Greg Pierce, who might be around at some point in the future. But anyways, he is a person we met at this workshop and started doing some work on the problem and essentially pointed out that the weight condition was wrong, and that with less than T equivocations, we can cause the safety oracle to break in some cases and essentially cause the estimator to switch to a different value. And so essentially what he was able to show is that if we want 1/2 plus T over 2 fault tolerance, we have to have more levels of agreement than just 2 levels of agreement. In that, like, they have to see each other agreeing, and in the messages where they see each other agreeing, they also have to see each other agreeing, and in those messages justifications, they also have to see each other agreeing. And it kind of exponentially approaches 1/2 plus T over 2, and it was pretty interesting. It was cool because we thought we had a safety oracle, but it wasn't a safety oracle in the sense that we thought. If you're only looking for 2 rounds of communication, there's a simple fix in that you just insist on a safety oracle that is 1/2 plus T. And this is enough to, if you have a clique of size 1/2 plus T, it doesn't really make sense for some T's, but with just 2 rounds of agreement, you can still detect safety. So let me step back for a second and summarize. What we thought we had, again, as a safety oracle, the condition actually wasn't correct. And we need to do one of the 2 things. We either needed to strengthen the weight condition, or we need to look for more rounds of agreement if we're looking for a safety oracle for the class of estimators that we have been thinking about, namely these estimators called majority-driven estimators.
Latest message majority-driven.
Sorry, yeah, latest message majority-driven estimators, which is pretty interesting and was a bit surprising, but it's pretty cool. So some interesting kind of analysis about this is that notably, to get the same amount of fault tolerance that one might get in something like Casper FFG or PBFT or something, it requires more rounds of communication between validators, which increases essentially the latency to finality for kind of any property, at least for this safety oracle, given what we can detect now, which is interesting. The theory is that this is essentially a property of the estimators that we're considering. So we're considering these latest message majority-driven estimators, which means we only look at like the weight of the last message from that validator. And so when a validator switches, essentially, from one thing to another, their weight kind of double counts, because on top of decreasing the weight for the thing they switched from, they're also increasing the weight of the thing they switched to. And so you kind of get a 2 times their weight effect on, the relative weights of the people who agree and disagree with this any given.
Unless they're seen to equivocate.
Yeah, unless they're seen to equivocate, sure. So we have kind of again, we have a way to fix it. It's either insist on higher weight conditions or wait for more rounds. And then you can kind of, we believe we're going to be able to show that it is a safety oracle in that case.
Want to state or write down the equation for the clique size, the number of rounds?
Oh, shoot. I don't know if I have it on me. I don't know if I can pull it out of a hat either. It's kind of crazy, but wait, give me a sec. Let me see if I can find it.
I pretty much remember it's like 1/2 of the total weight plus 2 to the K over 2 to the K plus 1 minus 1.
Yeah. So K there representing the number of rounds that you go back. So by the way, we're, 1 second, sorry. Yeah. So 1 round of agreement is, what we currently have our clique oracle at. If we strengthened our clique definition and added 2 rounds of agreement, then we would set K equal to 2, et cetera, et cetera. Okay, I do have it here. Yeah, here it is. Hello, my video is on now. Oh, no, it's super dark. This is the formula. I don't know if you guys can see that. If you want to take a screenshot, I don't particularly have anywhere to type it out, but essentially the clique size has to be greater than 1/2 plus this coefficient that Vlad mentioned, which is like 2 to the k over 2 to the k, 2 to the k over 2 to the k plus 1 minus 1, minus the coefficient times the relative amount of equivocations that we're seeing at any given height. So it's a little bit of a complicated definition when you start thinking about how to deal with like equivocations that are seen by certain validators. And to be honest, I don't have super good intuitions on why it looks the way it does, why the equation looks the way it does. But I'll type it up today and send it over to you guys, so you can check it out, because it is interesting looking for sure.
Yeah, great. We would definitely appreciate that, because obviously this means we have to fix the implementation that we have.
Yeah, the simple fix, I would say, is just wait for a clique of bigger size. For some fault tolerance thresholds, it doesn't necessarily make any sense, and so you actually do kind of have to, depending on your fault tolerance threshold, you might have to do more work. But like if you have a fault tolerance threshold of less than 0.5, you essentially can kind of just increase the weight, the weight of that you wait for the clique to be before you make a decision, and it's like fine, and you don't have to do any more work really. Just kind of wait longer.
Okay, that sounds easy enough.
So basically just like set the clique to like, so if we have a clique of majority size, then we kind of like, you could like assume that that's like a 1/2 plus t size clique, for like some fault for fault tolerance. If you have like meaning that clique, if it agrees on something, will have a property that agrees for that fault tolerance t, meaning that like unless there's more than that faults, then it's gonna hold.
Yep. I think. I mean, the proof isn't completed, but yes, it seems like that.
When do you expect the proof to be written down?
Yeah, I guess I'm not sure, Vlad. I mean, it seems like fairly high priority to me, but I don't know, Vlad. What do you think?
Well, I mean, our plan was to finish the kind of example protocol section first, but basically, so we have like, I guess right now we have like a solution without a really pedantically written proof, and we're like, it's definitely a priority, but we're also gonna try to rope Greg into helping us with the proof. But yeah, I mean, I mean, we definitely plan on writing the proof.
Cool. Any other updates on your end?
I think that's it.
Cool. Michael? Ken? Is Kent on?
Yep, I'm here.
You guys want to give an update?
So on my side, just more implementation stuff. Basically finished up with the block store integration. We also, I guess one sort of researchy thing, although this might have already been known, is that we decided to make sure that you need to have, we have this validity condition in which the justifications in the current block must match the bonds of the creator justification of that block. And well, the creator justification is defined as the justification block that was created by the creator of the current block. So they have like the same sender. And yeah, like when I say the justifications match the bonds, I mean there's the list of validators that create the justification match the list of validators of the bond. So that's I guess one other validity condition that we've added in.
What do you mean that a list of validators determines the validity condition?
Well, so
Validators justification.
So you know how a block has justifications, right? And then so the justifications consist of, it's basically a map, right? From validator to a block, or technically a block hash, right? And so we're assuming we're not doing this efficient justification thing. We need to have all the validators that are currently bonded according to some block, right? So it was kind of ambiguous, like which block we're going to choose. And so like my first intuition was, well, maybe we should use the parent block. But then you get into this sort of self-circular loop where you can justify your parent block by choosing a subset of validators to pick your justifications from. And so we settled on using the creator justification, as I just defined, to so your creator justification essentially tells the world that, hey, here are the current bonds that I'm keeping track of, and so my next block will have justifications for all the validators that I have just said I'm keeping track of in my bonds or through my bonds.
So is this like, as opposed to, say, for example, holding two sets of validators for like the one block that's pivoting, that's changing the validator set? Or
wait, two sets of validators? What does that mean?
I don't know. So it sounded like you're saying like, oh, look, imagine if we have like a change of validator sets and we want to justify our change of validator set. We need to use the old validator set to justify the for choice rule up to the point where the new validator set is induced.
Yes, that's true.
And then after that point, the new validator set is in charge, right?
Yeah, exactly.
The one way to do it is to have like two maps from validator to latest block in the justification.
Two maps
Like
for
one for the older validator set and one for the newer validator set.
Oh, so I guess the bonds act sort of as that second map, if that makes sense, right? Because the bonds list exactly who the new the new validator set is.
Yeah. So what I'm trying to figure out is like, why not just use two? So it sounds like what you're trying to avoid is using two justifications.
Well, we already keep a cache of the bonded validators, so might as well use that, right? There's no reason to, like, if we had a second validator set, then that would be like we would have 3 copies of the same thing on most blocks.
You mean because you're already keeping their bond?
Yeah, and that acts as the what.
Okay, so do you want to describe the validity condition again? Sorry, I think I might not be following.
Oh, so the validity condition is that the current block's justifications map, like let's just say it's a map, the validators, or like the keys of that map, which are the validators, must match the creator justification block's bonds validator set.
So does that mean the validator the block who introduced the new validator set?
The creator justification block is the, if starting from the current block, if you take the justification block that was created by that same creator of the current block, that is the creator justification block. I like, maybe the naming isn't so good, but I didn't see, like, you never really specified in your CBC paper like how to call that block, if that makes sense.
You mean the validator change block, or the validator rotation block?
Not the validator rotation block, but basically the block that
Or that from the same sender?
from the same sender, exactly. The previous block from the same sender. Yeah.
The one before the one that they introduced the validator block.
Sure. I mean, just regardless of whether the validator set is changing or not, like just the.
Okay, so if you're saying for any two successive messages from a validator, you need like what's the validity?
Oh yeah, okay. For any two successive messages from the same validator, you must have the latter message's justification maps keys, or basically the validators, to be the same as the previous of the two successive messages, or like the former spawns validators. They must be the same.
Okay. So in every block there's like a place where the bonds are kind of listed.
Yeah. It's a cache that is pulled out of the proof of stake contract.
Right. That makes sense. But that like isn't the validator set of this block, is the validator set of the next block that you make.
So yeah, the bonds of the former end up being the justification of the latter, right? Like, and so like you can change the validator set in the latter block again, for example, but the justifications, you need to point to all the validators that you said you would look at in the former spawns.
Yeah, no, I mean, I think that makes sense, but I'm not sure this is the best way to deal with it.
Are you saying that we should instead use the parents?
No, I basically, so like the kind of discipline is that we have is that like each of the different, because each of the, in some way, every different validator rotation is running a completely new consensus protocol. And so like in some way, the thing that's necessary is for every message to kind of indicate what validator set they're using. But there's, for example, no reason why you shouldn't be able to continue making messages under the old validator set, or why messages under the new validator set should influence your choice under the old validator set. Here's kind of a question. Imagine you have a validator who's bonded in both of the validator sets. Do you count their weight in the older validator set when they make a new message in the new validator set?
Well, you can only swap or rotate your validator set once per block, right? Like the current block sort of specifies exactly what your new validator set will be. So like you can, like, I guess I'm confused. Like, how do you get two different validator sets? Like,
well, so I mean, every time the validator set changes, it's like a new validator set. I'm not saying it's the same block.
Okay, but that's because.
So imagine if, like there's like one validator set for 100 blocks, and then like another for another 100 blocks. And like imagine there's like a validator who's in both sets.
Yeah. I see. So I guess what you're saying, I guess this is not about weights. This is just about which blocks you'll be referencing, right?
It's also about weights, right? The question I asked is like, does this validator have like different kinds of messages, or do the same messages count for weight in both epochs, or I don't know, validator regimes?
Well, in terms of the weights, we always use the parents, right?
Yeah, but like the question is kind of, do you give them a new name when they are introduced in the new validator set? Or do they use the same name as before?
Oh, I see. They use the same validator ID as before. Yeah, as of the current implementation. Yeah, I see.
So somehow there's like the simplest thing to do is to make everyone use new names when there's any validator change.
Yeah, that makes sense. Yeah, I see.
And then to allow a validator set that hasn't, to allow validator sets, the validators from earlier sets to continue making messages to finalize those blocks, even as and after the new validator set is inducted.
Yeah, that makes sense.
Because right now, kind of the question is, okay, well, imagine if there's a validator set change. What is the default behavior of the validators? Will they continue making blocks on the new chain if they are unbonded, just so that they continue finalizing the previous one?
I guess we haven't. I mean, we definitely haven't implemented any solution there. Like, yeah, I guess. It seems like it makes more sense to just be able to swap between. Yeah, I guess when you try to push the old validator set chain further, then you would have to use your old ID, and then for the new validator set, you would have to use your newer ID.
Yeah, so that's certainly the easiest thing to do from the point of view of like thinking about the protocol is to run effectively completely independent protocols for every different validator set. And so like to literally just have like a completely disjoint protocol, and this is a bit why the cross validator set justification validity condition makes you feel a little bit weird. Because the previous message from the same validator may not exist if there's been a validator set change in the same way.
Yeah, or like your bonds will be completely different from the justifications, or like what the IDs in the bonds would be completely different from the justifications, right?
You have the sender who you're trying to look at the previous block. Yeah.
And I guess that's fine. I guess immediately my next question is like, well, how do we generate the different IDs? And then,
well, so I mean, the my personal preference is to use the block of the hash of the block that they're inducted in,
and then you append that to their original ID or something like that.
Yeah, or there's two options. One of them is you say, oh look, this is a validator with this pub key hash from this dynasty, or you can just create a new ID by hashing them together.
Oh, I see.
Or you can
actually, I guess both work. Yep.
Is currently their ID their public key, their account number?
Yeah, it's their public key.
Hash of public key?
Yep. Encoded in base 16. Yeah.
Have you guys decided on a digital signature algorithm?
So we support ED. What was it again?
None?
Yeah, I think so. The one that Ethereum uses. I forgot off the top of my head. Yeah.
Yeah. Okay. I'm not sure if we would have made the same decision today, but it's. Do you have a reason for that decision?
Well, we wanted to support Ethereum keys. I guess it's because of the way we're doing the airdrop, I think. We're planning to support more keys, but like we have to at least support the one Ethereum does for that airdrop.
When is the airdrop?
I'm not sure. I guess Greg's on the call.
It's not an airdrop. Let's not call it an airdrop, please. Let's call it an issuance. Maybe those are the same things, but
Okay.
Sure, issuance.
it happens at the launch of mainnet. So those accounts will be part of the Genesis block. In essence, we're going to scrape addresses and amounts off of the Ethereum blockchain from a specific block height, and then we will input those addresses. We will put a different prefix in front of them. They'll be RX instead of 0x to designate that they're RChain addresses. And then we will create those addresses on the RChain blockchain and allocate an equal amount of Rev token to those addresses at the launch of Genesis.
Okay, cool. Anyways, we can talk about this some other time because I guess we might still have Casper stuff. But okay, noted. So ED 25519. I mean, I would say that most of the cryptographers that I know right nowadays like prefer Schnorr signatures. But it's not a huge deal.
We're extensible though, right? So the signature message includes the signature itself, the public key, and the algorithm is another field. So we can choose to support new algorithms in the future.
Cool. And so you have a separate message type called signature?
There is a separate message type called signature, though I think right now the block doesn't use that message subtype, but all its fields are in there because the new message type was introduced later. There's some cleanup we need to do around our protobuf.
But actually, it can be useful to send the signatures separately from the block, right?
Yeah, totally. Yeah. So we have defined now a separate message type called signature, but it is as of today not used for day-to-day block passing. It's only used in an earlier part of the protocol.
Okay.
Like the launch.
You have signatures on blocks nowadays?
Yeah, we have signatures on blocks, but it's not factored in the same way.
Oh, I see. Cool.
But we at some point should go back and clean that up and sort of be consistent.
Yeah, another thing that people will want is to have staking pools. And that's like a thing where it could be improved a little bit by allowing custom signature schemes, but definitely not like a high priority thing.
Yeah, we don't allow totally custom ones because we still need to know how to validate it, right? And so it's just a string like ED25519 that gets used today. And so you can sort of specify sort of the short name of well-known signature algorithms.
Sure.
Yeah. But yeah, maybe someday we'll let them pass in a whole contract. I don't know.
Yeah, exactly. So the idea with abstraction is like, you have like a verification component of a smart contract. So. But yeah, absolutely. I hear you.
I didn't totally follow though why having new IDs is important though.
Oh, so I'm not sure. I'm not sure that that is important. But there definitely is a lot of thinking to do that if you don't have new IDs that you don't need to engage in if you do have new IDs. So like I can't tell you right now off the top of my head like why not having new IDs is going to cause a problem for you. But it's just not really a part of the spec right now. It's like it's not covered. It's not like the way that I'm like intending right now for the validator rotation to happen, given like the state of the spec and everything, is to literally tile instances of consensus protocol with like different Genesis states essentially, or different like Genesis blocks. Because that way, like, we're sure that we don't have to reason about anything new, right? There's no like new cross-validator set phenomenon at all. Like they just don't exist. Whereas if you just have like a single validator set or a single validator that can exist on two multiple validator sets, they can, for example, make a message on a block that like other validators don't. I mean, so the other validators will have to like learn about the new validator set in order to process it. And in some way, that might increase the efficiency of the protocol, because you might have like fewer orphan messages in this case. But it's definitely more complex. I don't know.
Yeah, no, I see what you're saying about the complexity, but I do think it's worth it though, because of the efficiency gains, right? Because
so we're talking about it depends on how often you change validator sets, right? I mean
yeah, that's fair. Yeah,
efficiency gains are significant if you change every block, but I mean very significant if you change every block, but basically like almost non-existent if you change every like 100,000 blocks.
Yeah, got it.
I don't know. I could use another opinion. I don't know. Nate, what do you think? Nate, are you around still?
They just put a message in the chat saying he had to drop off. But
oh, okay.
We can table this, talk about it another time.
But basically, well, I mean, we could reason we could try to reason it through. So, imagine that you have a validator that's making a block in a new validator set's blockchain, but which was inducted in the previous validator set, which is not in the new validator set. So it's pretty clear that new validator's block shouldn't contribute any weight to the new blocks, but does contribute to the old blocks, right?
Yep.
Having no weight in the new blocks, kind of what that means is that it's never going to be the tip of the fork choice for other validators in the new validators. There's kind of two modes. One of them is if there's any weight at all competing with them, so they can't have any weight, and the other is purely at all, because it might be that those validators are just completely blind to those blocks, because that validator has no more weight. So a validator who's unbonded, making blocks on new blocks that are from the new validator set, is definitely has a disadvantage, and depending on how it's implemented, will either be ignored or will lose against any non-zero weight block. So if let's assume that they're ignored, then all of their blocks, all of the unbonded validators blocks on the new chain will be kind of orphaned by the new validator set, which is fine. That doesn't get in the longest chain. It still can be received by everyone who's running the consensus protocol for the old validator set, and could be used to update their kind of a consensus stuff. They can upgrade the fact that they're agreeing, but what they do have to do now is to download blocks from the next validator set, which they didn't have to do previously. I guess because the new block from the old validator set has a pre-block pointer to new blocks from the new validator set.
Yeah.
So which I think like might be totally fine, because that might be successfully inducted and you might have to download those blocks anyways. Or it might be less fine because that validator set induction might fail. And then you have to download all these blocks and keep them around, even though that new validator set is completely, that new validator set is never, eventually turns out is never induced. So that's a mild inconvenience in the event that the new validator set isn't introduced. So if we have a validator set that's like, kind of introduced and then forked off, if the old validator set has to point or gets to point to the new validator set's blocks, then we need to keep those blocks around, even though that validator set is kind of like a ghost validator set. So that's like a mild inconvenience.
Well, I don't know. Isn't that an argument about like all forks ever? Right?
Yeah, in some way, absolutely. But the difference is that now we don't need to keep. The difference is that like usually that doesn't involve keeping track of new validators. But you're right; it's totally not dissimilar to having to keep blocks around, orphan blocks around ever. So that's the case of validator who isn't in the new validator set, but is in the old one. The case of validator in the new validator set, but not in the old one, is pretty easy. the case of a validator isn't in either is pretty easy. The last case kind of is just where there's a validator in both, where you have a validator that's in both of the sets. And it's totally fine for their weight to contribute to the old validator set. And the question is like whether their participation in the consensus in the new validator set will be affected by the fact that they were the old validator set. Well, the immediately obvious thing is that they are capable of cross-validator set equivocation, which I think should be I think that should be fine. That their weight applying to Ghost seems like it'll just work in the same way as before. Yeah, I mean, I don't know. So maybe it's fine, but basically what ideally you would be able to argue that with a proof as opposed to just kind of like with more of a heuristics approach. But somehow like though I'm much more sure that it's fine, or relatively much more sure that it's fine to just have completely disjoint validator sets, to have different validator sets. Start with an intersection. It does mean that we have to think about cross regime validators. But I don't know. I haven't run into any serious problems yet. But I think it is kind of cool that we can do it without having them be running the same protocol essentially.
Yeah. Okay. Makes sense.
A contract will be determined the choices of validator sets, changes, and accepting changes. So each validator could have its own rules for how it does this. I mean, we might recommend something. Is that correct?
Well, so the smart contract manages bonding and unbonding. The validator might have some influence in, over what transactions get in there, but they shouldn't be exercising any discretion. They should just be allowing all the bond transactions. Although I don't know how this is going to fit into the kind of sidechain model, but definitely like for the root chain, I would hope and assume that validators would just freely allow anyone, and that the bond contract will select validators.
Yeah, so on a related note, I heard that there was a decision about the validator, or like the spreadsheet. Everyone knows what I mean. But I had a question relating to that, and that's specifically that the spreadsheet said that there will be fees. And so I just want to break down that a bit. And so if you have a side chain, right, like you have no control over the fees or the joining fees on that side chain, because the validators who create that side chain can decide whatever they want for it. And so really what that means is the joining fee is really only about the root chain, right? And so what is the, like, on chat, at least I saw.
Did you mean that that's the only joining fee that we need to decide, or?
Yeah, like if there is a joining fee, then that's the only thing we need to decide, or we as like the cooperative, or as people who are running the root chain. And yeah, so I saw on the public Discord that Mike Stay said that there'll be no fees for, or probably no fees for, the root chain. But like what was the consensus there? Was Greg?
Yeah, I mean, if there is going to be any fees for the root chain, it's going to be quite small.
I see. So we haven't specifically decided yet. It's just that it's either going to be none or small.
That's right. Yeah, that's all.
Okay. Is there? I guess
because the root chain is meant to be super public. That's the idea.
Exactly. Yeah.
Great. Excited to hear it.
I guess I was hoping that maybe we could decide. Like I mean, none or small is kind of, it's a big difference in terms of implementation, right? Because like none means we literally have to do
have like a parameter that could be 0.
Yeah, exactly.
So we're not, it's just going to be, if there's a fee, it's going to be some literally like an integer. Like there's no fancy functions or.
No fancy functions.
Okay, cool. That sounds good.
So constant.
Yeah, that's cool.
I'm not sure. I mean, the problem with constant fees is they could go up and down, and there's nothing you can do about it. Sounds ironic, but it's because of the underlying cryptocurrency volatility.
Yeah, it would be hard, or I guess you would have to hard fork the protocol to change it to something reasonable if it gets out of hand.
Mm-hmm. Which may not be unreasonable.
Yeah, okay. I mean, I'm happy with just inserting a constant. So, yep.
Yeah, I prefer that over letting the validators decide. So,
yeah, that's for sure.
Cool. On my side, I have another update. We haven't really covered yet. I made a bit of progress abstracting the CBC Casper safety proof to handle additional information that could be sitting around in the state and not have it kind of break down. So basically, by defining two things, one of them is an equivalence relation over protocol states, and the other is a plus operation over protocol states. And basically, the idea is that like plus is going to take the role of the union, and our equivalence relation is going to take the role of like equals in the safety proof, where like we kind of say that, oh look, if there's not more than some number of faults in the union, then there is some future state that they all have in common, namely the union. We have like a more abstract statement of the proof now. I'm still working on to make, but basically, the plus operator takes two protocol states and returns to another protocol state. It's commutative and associative, and two states are equivalent according to this equivalence class if they have the same fault count, the same estimator, and the same fault count and estimator for themselves plus anything. And so the idea is that this lets us erase any information that isn't relevant to the fault counter or the estimator, and the fault counter and the estimator are the only real subject of our safety proof in some way in terms of the protocol states. And so I basically have created some room for varying the structure of protocol states and of state transition while preserving the safety proof. As long as you can kind of create this plus operator and then kind of everything is golden. Still working on the details, but basically I'm working on abstraction, and I'm going to continue working on abstraction. I think for a while I'm going to try to get to. Eventually, the goal is to have be able to express light nodes and sharding solutions in the like formal CVC Casper framework, and not just like kind of, but really, really with the validators, like not having to look at all the justifications and stuff like that, like kind of where we can talk about in the protocol the fact that they only have block headers.
Yeah, that sounds cool. Wow.
Yeah, it's pretty cool. Does anyone else have any updates?
Just a small one, Vlad, on that synchrony constraint thing we were talking about.
The constraints on an interpreter.
Yeah. So it turns out that there's a cleaner way to do that, which is the context driven com rule. So I can show you that later. But first of all, with as I mentioned, the row calculus, or the mobile process calculator. I mean, the whole métier, their raison d'être is the being able to reason about synchronization, right? That's what the model of computation is all about. Is computation proceeds by synchronization. That's what the com rule is. And now, if you want to enforce, if you want to add more stuff at the synchronization point, then the best way to do that is to have a context com rule. So you put you have a context which envelops the substitution at the moment of the com rule.
So is it where do you write this down?
So it's a parameter to the com rule. The com rule takes a context, and then when you do this,
how wide could it look?
The context, it can be any old context, whatever. It could be.
Is it expressed in matching logic? Like it's kind of like it gives like a term variables.
The context is just a row calculus term with a hole in it. That's all it is. It's just, it could be any term whatsoever with a hole in it.
Or
and then when
holes,
and then,
variables.
The hole is a hole for a term.
Right. Yeah.
It can have variables because it's a term, but the hole is where you're going to put the term. And then at the moment of substitution, you plug in the term that you're sending.
Oh.
Into the context. And now that provides you with arbitrary control over synchronization.
Not really arbitrary. It's based only on things that are sent to you.
There's no other form of synchronization. It's like you synchronize at the point of, message passing. There's nothing else.
I'm not sure about that. I mean, like, so like there's like, for example, like imagine if, like one message arrives before another. Okay, that like, I could, okay, that could probably be done in your context. How about, so I guess what I'm saying is like, I'm skeptical that we can.
You just look, all you do is you just go down the list of syntactic constructions, right? Every single syntactic construction tells you something about synchronization, right? Input and output tell you things about synchronization. Parallel tells you something about synchronization. Parallel composition says they're not synchronized, right? Or they're potentially not synchronized unless there's a red X hiding in there. So I mean that's kind of the whole point of the calculus, right?
Yeah. Yeah, so I mean, I can definitely see how I can express some synchrony. The question is like, can you express like, for example, like a traditional synchrony assumption?
Yes, that's sort of the whole point of these calculi is that's what they do, that's what they're good at.
This is-
All synchrony assumptions can be expressed in this style, including and like the thing that was really hard for the pi calculus was the join style synchrony assumption, right? So the multi-body problem, right? But with the way I do the joins, that resolves that problem for these calculi, right? So that was the only one that was a stumbling block for this form, and
So I mean, I don't know how, for example, I would force nodes to make messages in rounds. So somehow I think
that's easy, right? You just write down the round-based protocol as a pi calculus process.
Yeah, so imagine like, there's like a timeout, you make a message, and there's a timeout, you make another message, there's a timeout, you make another message. So like what I'm saying is like the rounds aren't synchronized by signatures from a quorum of other nodes. They're just like they're synchronized somewhat magically.
If they're synchronized by timeout, timeout is easy to write down. Timeout is a race with a clock.
Yeah, I mean, I agree, but can you, for example, express like why should all of the races resolve so that all the messages with like some number less than some number arrive before a certain timeout?
Again, whatever you want to write down, you can write it down this way. It's very straightforward. I mean, that's why these calculi were invented.
But how do you insist that, for example, some event happens before a timeout?
How do you insist that a particular
you can't really put the timeout as a continuation of that event. That's like not really.
So let me make sure I understand what you're trying to say. Are you saying that either the timeout occurs or the event occurs?
I'm saying the event will occur before the timeout. That's like a synchrony assumption, for example.
Okay. And how do you? So you're saying that this is a constraint of the system. This version of the protocol, in all versions of this protocol, this event will occur before the timeout.
Yeah, under the synchrony assumption. Yeah.
Wait. What's the synchrony assumption? That's what I'm trying to get at.
That's the event will happen before the timeout.
Okay. All right. So, that one is much easier stated in the Hennessy-Milner logic, because then what you do, rather than encode it in terms, you encode it as a logical proposition, and then you only look for those terms that satisfy the proposition.
Yeah. So this is kind of totally kind of the kind of thing like this is the kind of thing where like I was thinking about a constraint on the interpreter and all the ways that the term could evolve was subject to this additional constraint, because I didn't think that I could encode it actually just in the terms. Although now more and more you were making me think that I could maybe rewrite the term to get a new term that has the synchrony assumption.
Yeah, for sure. But it just depends on what you're trying to do. If you're trying to get a a collection of terms that satisfy a particular constraint, then the logic is better. If you're trying to sort of give the mechanism by which it happens, then the language is better.
I guess what I want to do ultimately is to develop the infrastructure required to like give a correct by constructed liveness strategy, and from a Leibniz proof. So I want to be able to just to describe, for example, all synchrony assumptions, to describe all strategies, and be able to search kind of to do a correct reconstruction approach for aliveness, like I've done for safety.
Okay, so from that point of view, then probably the way you parse it, or way I would parse out what you're trying to do is your synchrony assumptions are written in Hennessy-Milner style formulae. So like in namespace logic would be an example, or in the spatial behavioral logic of Kairos. That would be where you write down your synchrony assumptions, and then you look for terms that satisfy those assumptions.
Mm-hmm.
Right? And your terms are correct by construction if they satisfy all your assumptions.
Well, so the aliveness claim is going to look like something like, if you execute this term enough, eventually you get safety on some property.
Sure.
So I'm not going to have to look just at terms, but I'm also going to look at their executions, right?
Yeah, I mean, what you're looking at is modal formulae, right? So, from the state represented by this term, you can get to another state represented by another term that has this property, like safety.
Yeah. Or you can get to another term, which can get to another term, which so yeah, there needs to be like a recursive definition so that you take like any number of steps to get there.
Yeah, exactly.
Yeah, so I mean, it's kind of challenging, but
that's not challenging, right? But there are the Hennessy-Milner logics come with fixed point. That's so recursion is a part of the logic.
That sounds potentially useful.
Yeah.
Sweet.
Yeah. Cool. Are we? Is that all the updates?
Do you guys have a dev stand up right now?
Oh shit! I'm sorry.
Yeah, we're a little over time.
All right, I got to jump over. Sorry, I thought we were.
All right, bye, Greg.
All right.